Alrighty. Goal for today, not missing sides, missing angles. Real quick, this little life hack will make your life easier right out of the gate. You know we're dealing with right triangles, right? So there's always going to be a 90-degree angle in the triangle. Okay, I have a question. Does anybody remember what all three angles in the triangle add up to? Go ahead, Bree.
Was it 180?
It is 180, yeah. So all three angles in a triangle add up to 180. So, okay, follow-up question. Since we're dealing with right angles, or right triangles, I should say, sorry. Since we're dealing with right triangles, one of the angles is already 90. So the question I have, and this will save you a minute on tonight's assignment, if you're asked to find both acute angles. If one of the angles in our right triangle is already 90, and all three angles have to come together to make 180, do you know what these other two angles have to add up to? I'm going to ask the question one more time, make sure it goes in. So if the angles in a triangle, all three add up to 180, and one of them is already 90, the question is, what are these other two angles? What are they supposed to add up to? Yeah, 90, perfect. So when you're going through your homework tonight, I mean, you can do it the long way or the short way. You can solve for these angles using SOHCAHTOA. Like, you can do that twice, set up two equations, solve. But I just think it's faster to use SOHCAHTOA to solve for one of the angles and then just subtract that answer from 90 to get the other angle. So that's a little hack. But we'll talk about that in a minute. I just wanted to set you up for some success on your homework in advance. But yeah, let's just, we walk before we run. We're just going to start by finding one angle. Okay, so yesterday, and the problems start exactly the same, just reviewing from the warm-up, the idea of SOHCAHTOA, right? So I don't know if you need me to write it down, but I will, Remember that SOHCAHTOA, oh, my stylus today. So we have SO. Just reviewing what SO stands for. That means that the sine of our angle theta is equal to the ratio of the opposite over the hypotenuse. Cosine, or ka, in SOHCAHTOA, that means that the cosine of an angle theta is equal to the ratio of the adjacent side over the hypotenuse, our longest side. And then last one's always that TOA. And TOA stands for the tangent of an angle is equal to the ratio of the opposite side over the adjacent. So notice on the right side of the equal sign, we always have sides of the triangle. And then on the left side is where you have your trig function and your angle measure. All right, so first things first. Just like yesterday, I pretend I'm standing at this missing angle measure. We could call that missing angle. They call it question mark. The big kids are going to call it theta, right? So you pretend that you're standing on that angle. From there, you want to label what sides they give you. So for instance, the 8, that's all the way across from our right angle, which means that's very special. It's so special we call it the hypotenuse or the hippo. Big, smelly, hard to work with. And then right next to our theta, we have this 6. The side length is 6 here, right? Notice that side is next to theta. And the word we use for next to in this class is adjacent. So what they're actually giving you when they give you the 6 is the measure of the adjacent side. Based off of this information, you select. Again, step 1 is multiple choice. Are we looking at SO, KA, or TOA? And when I look at this, I'm like, oh. Well, they're giving me the adjacent and the hypotenuse. Adjacent over hypotenuse is the ratio we have for cosine. See that? Adjacent over hypotenuse. So since they're giving me the adjacent over the hypotenuse, I'm going to grab up my cosine formula. I'm going to fill in what I know and solve for what I don't. So in this case, I don't know what theta is. That's what I'm trying to find in the problem. So the cosine of theta, I don't know what that is yet. And that's equal to the adjacent side over the hypotenuse. So our adjacent side, right there, see ADJ, adjacent is 6. So the numerator of this fraction is going to be 6. And then the hypotenuse, that's the number that's going to go in our denominator. The hypotenuse in this problem had a length of 8. So I'm going to fill in the 8. You could reduce if you want to. Now, what's interesting is I got to solve for theta, right? Well, back in the day, don't write this down. This is wrong. Don't write this down. Back in the day, you know, if you didn't see an operator, you kind of assumed it was multiplication, and you would have like tried to divide both sides by cos. But that's like trying to divide by like a square root sign or a plus sign. Like you can't do that, right? So the idea is we need to get rid of that cos. We need to get rid of that blue COS, and you can't, I mean, you can't really divide it. So I'm going to erase that because that was wrong. Bless you.
Thank you.
Okay, so can't do that. What I can do, however, I wish I had your cool notability function. I need to get rid of this. I need some space. Y'all can like just snip things and move them around. But yeah, I'm going to move my TOA. I got to get rid of this blue cosine here. And to do that, instead of dividing both sides, I'm actually going to introduce to you this idea that you could do cosine inverse. That's how you read that. The little, I don't know if you remember that from your Algebra 2 class when you did the inverse functions right around this time in your Algebra 2 class in February here. If we do the inverse cosine times cosine, they kind of cancel each other out. So that theta is all by itself. However, what you do to one side of an equal sign, you have to do to the other, right? So if you did cosine inverse on this left side, that means we got a cosine inverse 6 over 8. And then that's just what you type in your calculator. What's up, Jaden? Let's just get through this real quick and then, yeah. Is that okay?
Yeah.
Yeah, so we're going to go ahead in our calculators. Do cosine inverse of 6 over 8. And I got about, so just type in that in your calculator, make sure it's in degree mode. We got 41.41. Notice I solved for an angle measure. So that's degrees right there. 41.41 degrees is the measure of that angle. Looks about right. It's definitely acute. Maybe about half of 45 there. Usually the diagrams in geometry don't lie, so it's kind of nice. All right, and this is what we're doing today. We're solving for the missing angle. This is our lesson. So step 1, just running through. Step 1, we identify, do we want to use sine, cosine, or tangent? We fill in what we know. And then today, to solve for what we don't, we have to take the inverse trig function on both sides. So that's what allows us to get theta by itself. All right, number 2. So the big kids are going to call that theta, right? So I have theta, and then, oh, they give me all the information here. That's so nice. They give me, just labeling, they give me the hypotenuse. They give me the adjacent side. And then they also give me the opposite side. So you get to pick if you want to do sine, cosine, or tangent. I don't know. Anybody like one more than the other? What do you want to do, Brie? Sine. I like sine too. That's a nice safe choice there. Yeah. So if we do the sine of theta, that's equal to our opposite over our hypotenuse. So we fill in what we know, we solve for what we don't. We don't know what theta is. So sine theta on that left side stays put. The opposite side up there is 14. And the hypotenuse was 50. Now the only thing in the way is that sine, that sin, you know. So that's what we're going to want to go ahead and get rid of. In today's lesson, the idea to get rid of that sine on one side, you multiply it by its inverse. So the sine inverse of sine, those things cancel each other out. What you do to one side of an equal sign, you got to do to the other. So I'm going to bring the sine inverse down there too. And we have 14 over 50. So I'm going to go ahead and press second sine of 14 out of 50. 16.26 degrees. I use the about symbol. All right, we got two more. All righty. So taking a look at theta right there. Once again, hey, we could just do one of each. We did sine, maybe we'll do cosine, then we'll do tangent, so you can see how they all get set up. So we have our opposite side. We have an hypotenuse here. Oh, that's not the hypotenuse. Sorry, Friday brain got me. That's the adjacent side. My bad. 34, that's our hypotenuse. You guys good? Yeah? Okay, cool. So this time around I'm going to do cosine, you know, because I can. They gave me information about the adjacent side and the hypotenuse. So if I'm setting that up, cosine of theta is adjacent over hypotenuse. I don't know what theta is. That's my goal. Adjacent side's 30. Hypotenuse is 34. Then I need to figure out what theta is. This time around, to get rid of that cos, I'm just going to multiply both sides by cosine inverse. So we have theta equals, you got what you do to the left side, you got to do to the right side. So you got to bring down your cosine inverse there of 30 out of 34. And now it's just your calculator does a lot of the work for you today. So I'm going to press second cosine of 30 divided by 34. Thank you for clicking along with me. I hear you tapping your buttons. Nice job. 28.07 degrees is what I got. Hopefully you did too. That looks about right. Almost like a 30-degree angle. Looks like it might be close to a 30, 60, 90 triangle. Last one. I'm going to do one with tangent. That'd be good. Let's do that. So if you take a look, there's theta, where that question mark is. And they're giving me information about the hypotenuse. Across from theta, that's our opposite side. And then right next to theta, that's our adjacent side. So if we do tangent, so tangent theta equals, that's opposite over adjacent. So I don't know what theta is. So that left side stays put. Now I fill in what I know about my opposite side and what I know about my adjacent side. So my opposite side, that's 68. And my adjacent side, that's 51. That little tangent's in the way there, so I'm going to do tan inverse of both sides. So the goal of the day is to realize that you're just, to figure out the angle measure, you're just hitting a different button. You're using that little negative first button there. So I gotta press second tan, type in 68 divided by 51, about 53.13 degrees. And that's how you solve for a missing angle when you're given a couple sides. Not too shabby. So now we get to practice.